Okay, so in this video, I'm just going to do a bunch of examples of finding surface area of revolution. So I'm going to assume you kind of know the basics of this and you just want to see a few more examples. So we're going to find the surface area of the revolution generated by revolving the curve around the given axis. So we will start with x equals the square root of 4y minus 3. Y is between 1 and 3, and we're going to rotate around the y-axis. Okay. So really what you need to be able to do for this is you've got to know these two formulas. And so when you rotate around the y-axis for these, everything is in terms of y. So here's the formula that I'm going to use. So the big thing with this is we've kind of got to start by doing the work for what goes under the square root. So let's start there. So first I will take the derivative of this function. So I'm going to use the chain rule. So let's see, I take the derivative of the outside and then I multiply that by the derivative of the inside. And I want to rewrite this as nicely as possible, so this is all going to simplify to what you see here. And now I know that I'm going to have to square this, so let's go ahead and just do that. So let's see, this will become so this squared, I just square the top and bottom, so 2 squared is 4, and then squaring a square root just cancels out the square root. So here's what I get. Okay, so from here, now you've got to make some choices. So I am going to set this up, so from 1 to 3, 2 pi, okay, so I'm going to use the original function, 4y minus 3, square root of 4y minus 3, and then I'm going to multiply that times 1 plus 4 over 4y minus 3 dy. Okay, so this is a pretty classic trick that we're encountering in this problem. For this problem, the best course of action is to use what we know about properties of square roots. And the property that I am referring to is that, so if I have square root of a times square root of b, this equals the square root of ab. Okay, so what that means is that I can multiply these two square roots together, and I want to do so strategically. So let me clear a little space and let's look at that. Okay, so first I'm going to just show what it looks like to multiply these together. Okay, so here I am multiplying everything under one radical, and I like this problem because I think this is a little bit creative in what you have to do. So you could, FOIL this out, but there's another way that you can think about this where it could actually be that you just distribute all of this. So what is 4y minus 3 times 1? And then also, what is 4y minus 3 times this? And if I multiply this by this fraction, you can see that the denominator will cancel out and I'm just left with 4. This is a way easier trick to use than trying to FOIL everything, because then you're going to get like some crazy denominators and it's just going to be kind of a mess. So let's go ahead then and let's write that out. So this becomes 4y minus 3. So again, that's taking 4y minus 3 times just 1. And then if I take this times this fraction, the denominator will cancel out and I'm just left with 4. Okay, so now I actually have something that I can work with. So this is just going to simplify to 4y plus 1. So there you go. All right, so the original integral I could not have integrated. I had to manipulate a little bit, and now that I've manipulated this, I can just use substitution to finish this. So let's make a little more space. All right, so let's see. I'm going to go ahead and use u-substitution. So I can go ahead and set my u, my du. So I'll say 1/4 du equals dy. And then I'll just go ahead and flip my limits of integration. Why not? So let's see. If y equals 1, then my u, so if I plug y into this, that'll become 4 plus 1, so u will equal 5. And then if y equals 3, so if I plug y equals 3 into this, 4 times 3 is 12, plus 1 is 13. So here we go. So let's see, this is now going to go from 5 to 13. Let's see, actually, let's bring all the constants out. So the constants I'm going to bring out are the 2 pi and then also this 1 over 4, I'll just bring that out to the front. Okay, so now I'm just left with u to the 1/2 from 5 to 13 du. Okay, and so now I can just finish this. So this just becomes pi over 2 times, let's see, so this is u to the 3/2, and then write the reciprocal here. And I can evaluate this from 5 to 13. And just to keep the video short, I'll just show you what this equals. So here's the result that I would get. So I need a calculator for this. I think this is good enough for what we're doing. So there's the idea behind that. Okay, so let's move on to another fun one. So now I've got y equals 1/3 x to the 3/2 minus x to the 1/2. X is between 1 and 2, and I want to go around the x-axis. So in this case, so I'm going around the x-axis. So same integral, really. I just need to have everything in terms of x. So once again, I want to go through and I want to first find the derivative. And so the first derivative, let's see, this will be x to the 1/2, and then minus x, 1/2 x to the negative 1/2. Okay, so now I have to square that. So that is going to require a little bit of foiling. And I strongly suggest that you attempt to multiply this out. So it's this times itself. So you're going to FOIL this whole thing out. I think this is a really good algebra check for yourself. So I would pause here and see if you get the same thing I get, and then just hit play when you're ready. Okay, so I'll show you the result of what happens when I FOIL. All right, so I've got 1/2 x to the 1/2 times itself. So the 1/2 times 1/2 is 1/4. And then just remember, so I'm going to write this out just to make it nice and visual for you. So you add the exponents. Then I'm going to have this times this, so multiplying my outside terms. So I've got 1/2 times 1/2, or negative 1/2, so it's negative 1/4. So this is x to the 1/2 minus 1/2, and then I'll have a second one of these when I multiply my inner terms. So I can do that. And then I'm going to have plus 1 to the 4th. So now I'm going to take this times itself. So again, I'm just adding the exponents. So I just wanted to state that in case you needed a reminder or if this is messing with your brain. So what does this all come out to then? So this will come out to what you see here. So these just become x to the first. These become x to the negative first. 1/2 minus 1/2, so x to the 0 just equals 1. So this really is just negative 1/4 minus 1/4, so that's 1/2. Okay, so now I need to add 1 to that. So let's make some space. So I take 1 plus my derivative, squared, so 1 plus all of this. And so then we can see that I can add the 1 and the negative 1/2. So this is 1/4 x plus 1/2 plus 1/4 x to the negative first. Okay, so what is the deal with this then? So this is very similar, right, to what my FOILed out derivative was. The only difference, right, is that now instead of a negative, it's a plus. So what that means is that I can factor this really using, so think about this, right? This FOILed out equaled this. So now I just have to change this to a plus sign in the middle. So this is just going to equal 1/2 x to the 1/2 plus 1/2 x to the negative 1/2 squared. And that's going to matter for the next step. So now I can go ahead and set up my integral. Okay, so I totally forgot what any of the directions were. Okay, wait, where is it? It was between 1 and 2. Okay, right. So I go from 1 to 2 pi. So I take the original function, which was, what was the original function? 1/3 x to the 3/2 minus x to the 1/2. And then the square root of, so remember we did all the work for what goes under the square root. So now it's just this 1/2 x to the 1/2 plus 1/2 x to the negative 1/2 squared dx. Okay, and so now what happens is that this square root cancels out with this square. So I have still more work to do. So let's see. I've got this and then 1/2 x to the 1/2 plus 1/2 x to the negative 1/2 dx. Okay. Man, all right, so we still have a bit more work to do. So let's make some space. All right, and now it is time to partay. Okay, so I'm gonna just bring the 2pi out. All right, so once again, I think this is actually a great time for you to check your algebra skills. So the worst thing that happens, right, is you get this wrong. Not the end of the world. So try it yourself. You will get more out of the video if you try it. Math is not a spectator sport. Hit play when you're ready. All right, so let's see. I get 1/6 x squared because 3/2 plus 1/2 is, oh wait, yeah, 3/2 plus 1/2 is 4/2, which is 2. So sometimes the simple math is the hardest math, right? All right, so next I have 1/6. So let's see, this will be 3/2 minus 1/2, so that's 2/2, so that's just to the x. Then I have minus x, let's see, minus 1/2 x, just 1/2 x. So I take this times this, so that's negative 1/2, and then 1/2 plus 1/2 is 1. Okay, and then finally, minus 1/2, this will come out to be x to the 0. All right, are we having fun yet? All right, so now as I look through this, I just want to rewrite this 1/2 as something over 1/6, right? Because I've got 1/6x minus 1/2 x, so it would be a good idea to combine these. So I can write 1/2 as 3/6, just to save a little space. Okay, so what am I left with? 1/6 x squared minus, so 1/6 minus 3/6 is 2/6. 2/6 is 1/3. I have been doing math for several hours today, so hopefully I'm still adding right. You never know. Okay, and so now we can integrate. So I'll just go ahead and show you the integration. So just the final steps so I can save time on the video. Okay, so here's what happens when I integrate, and then if I plug in my limits of integration. Okay, so I ran through the calculation. I got to this. So ultimately, what I'm getting is negative 11 pi over 9. And so hopefully you're asking a very good question right now, which is, wait, this is negative and it's supposed to be area. Okay, so this can totally happen. And when this happens, you just have to know how to interpret it. So the check that we need to do at this point is we need to actually go back to the original problem for a moment. So here was the original problem. So did we make a mistake, or is this something else going on? Okay, so if I plug in these numbers, so what is y of 1? Y of 1 comes out to 1/3 minus 1. So this is negative 2/3. And then what is y of 2? Y of 2, I had to use a calculator for that, but it's negative 0.47. Okay, so the thing with surface area, like one of the assumptions in these formulas, is that your function is positive on the interval that you're given. So in the event that you have a function, as we do, where obviously it's negative, then all you actually need to do is put a negative in front of your integral. So basically, now that I know that, I want to just pretend that I am compensating by putting, let's see, actually maybe I'll put the negative here. So see how you can just put a negative in front and it's all good then. So then this becomes positive. So this is ultimately 11 over 9. Okay, so let's talk about one last fun problem here. So I have x equals 1/2 e to the y plus e to the negative y. So let's see. I'm going to go ahead and take the derivative. So that's just going to be 1/2 e to the y minus e to the negative y using the chain rule. And so then I want to square that. So if I square that, that's going to give me 1/4. Okay, and so then on the inside here, I need to FOIL this out. So I need to square this. So this becomes e to the 2y minus e to the 0 minus e to the 0 plus e to the negative 2y. And so that all equals 1/4 e to the 2y minus 2, minus 2 plus e to the negative 2y. Okay, so at this point now, I want to go ahead and just add 1 plus x prime squared. Okay, so I'm going to go ahead and actually distribute that 1/4 for a second, because that will help me kind of figure out what I need to do next. So this is my distributed 1/4. Okay, so when I add the 1, so that just flips the negative 1/2 to a positive 1/2. And so now really what you want to do is you just want to reverse engineer all of this. So this part here, right, this is distributing the 1/4. So I can take the 1/4 back out, and then I can probably factor this again. So let me make a little space. And let me factor out, the 1/4 again. So if I factor that out, this becomes e to the 2y plus 2 plus e to the negative 2y. Right, so if I take 2 times 1/4, that will give me 1/2. Maybe that messes with your brain a little bit. And then I can rewrite this as 1/4 e to the y plus e to the negative y. And again, that's going back to what it meant to square. So you kind of like play with that relationship. So just to come back here. So remember, I squared this and got this result here. So now the only difference is that instead of having -2, I have +2. So I can just rewrite this as a squared again. Okay, so now, what were we doing? Right, we were doing this. So now I can use the formula. Okay, so let's go ahead and set this up. I'll make some space. Okay, so I've just plugged in all the parts of the formula. So here's my 2 pi, here's my function. Oops, forgot my dy. And then here's the 1 plus that function squared. So all that work we just did, here it is. And so this I can totally evaluate. So first of all, let's note these 2's are going to cancel out. And I'll bring the pi out. So now I'm left with e to the y plus e to the negative y. And then, so the square root of 1/4 is 1/2. And then this is just e to the y plus e to the negative y. And then all of that times dy. Okay, so now I'm going to take the 1/2 out. And I just have to multiply this times itself. So that's going to give me e to the 2y plus 2 plus e to the negative 2y dy. So that's like the same calculation that we just had a second ago. So you can FOIL all that out to see that. Okay, and so now I can make some space and integrate. Okay, so let's see. Since I have a constant here, I'm just going to multiply by the reciprocal of the constant. Minus 1/2 e to the negative 2y. Okay, so that's what I do with these constants that I see here. I can just take the reciprocal out. Okay, and so here's where I'm at. So let me just show you everything plugged in. Okay, so I went ahead and I plugged in my constants. So remember, anything to the 0 power is just 1. So this becomes, when I plug in 0 into this becomes 1/2 times e to the 0, so just 1/2. So 1/2 plus 0 minus 1/2 is when I plug all that in. Okay, and so let's see. What ends up happening here is I get just, well, just all of this, right? So maybe I can factor out, I'll just leave it as is. So 1/2 e to the 6 plus 6 minus 1/2, maybe minus 1 over 2 e to the 6. Okay, and I'll just leave it at that. All right, so that ends this video. So if you found it helpful, please consider hitting the like button, and I will talk to you guys in another video. Thanks for watching.